Okay, let's start. So welcome to our talk. We will talk about schizophrenic files. And first, this is...
Yeah. Hi, so my name is Gynvael Coldwind. I'm a security researcher at Google and Dragon Sector at the CTF team. I'm the captain. As the slide says, I like hamburgers, and actually all opinions that I expressed during this talk belong to me, and they are not the opinions of my barber, my lawyer, nor my employer.
And I'm a reverse engineer, and I'm the author of a website called Corkami, which is about reverse engineering and visual documentations. So first, to introduce what we mean with the schizophrenic files, it's one file that doesn't generate an error. It's not about exploitation or crash here. It's working under two different tools or more, and each time giving a different output. So no errors, but something different. Also very important, it's not like the file is just comparing some internal version and then behaving differently. It's like made passively because of a discrepancy between the parsers, for example. So the reason behind this, for first, Gynvael and I have been experimenting with schizophrenic files independently in the past, and then together we have gathered enough material for a whole talk on the subject. The main reason was fun, because usually such cases don't generate any kind of security. Well, they could, but it's not like they will become a CV by themselves. So the first reason is fun, and then, of course, there are applications. So even if it sounds like fun, there could be several applications, like bypassing security in various ways. And one of the most famous examples is the Android signing bug, master key bug. So first, I'll hand it to Gynvael, which will talk about this topic.
Okay, so the first example, because we have quite a lot of examples here, first example is the zip file. Who is familiar with zip files? Okay, everyone, so just kidding. This is actually an expert from my talk, which was done in Polish language. I don't expect you guys, well, everyone knows Polish language, so let's do it in English. So the first zip trick, which was actually the Android master key bug, basically, in the archive, you can place a couple of files which have the same name, like the exact same name. Of course, you cannot compress these files from the file system, but you can change the names in a hex editor or whatever, right? So what this person did, and you should read this paper, it's actually pretty awesome, is he created an archive which had two files named the same way, and it turned out that the signing was checked on the one file, but actually the second file was what was used later on, which means it bypassed the signing because the file used for signing was okay, but the second one was totally evil. So this is the most simple trick, I guess, like having a couple of same names in the archive. Now the second trick with zip is actually a little more, this will take some more slides. And well, as you know, the zip file begins with PK letters, right? Wrong. So actually that's not true. Actually, nobody knows how to interpret a zip, but we'll get to it. So basically you start somewhere at the end. At the end there is something called the end of central directory, which is a small header which has a pointer to more structures which are in the middle. Now the problem here is that actually we don't know how big this header at the end is. Therefore, we don't know where to look for it. Because it has at the end of this header, there's a comment, and the comment has variable size, which means that the header can be anywhere from like just at the end of the file with no comment at all, or it can be, well, 64K to the beginning of the file with a really long comment. So this is the first problem, and it's actually not defined in the zip standard where to start looking for this, because we can look for it in two different ways, right? We can start at the end, and then assume we have a comment of length 0, and we look for the header there. But, and then we iterate. Maybe there is a comment of length 1, maybe of 2, and we move to the beginning of the file looking for the header, for the end of central directory. On the other hand, we can do it the other way. I mean, we can assume that there is a long comment, there is a 64 kilobytes of comment, and then decrease the size of comment by 1 and look there. So these are two ways which lead to schizophrenia, but I'm going to get to it. Because now I'm going to talk about something completely different, which isn't really different, because I'm going to talk about another header which is in the zip file. So what you saw at the beginning here This isn't the zip header. This is usually what we see there is a local file header. It's actually a structure which well, describes one single file which is in a zip, and actually there are quite a lot of local file headers in a zip file. So actually each file in a zip has this. Now, there's also something called the central directory. It's placed near the end of a zip file, and it also has an entry for each file which is compressed. These are kind of redundant, so if one is broken, you can always use the other, and there are quite a lot of problems with it. However, getting back to the point, getting back to the point of the end of central directory, if we find it, it actually has a pointer to the central directory. And in the central directory, there are a lot of files, entries for the files, and there's also a pointer to the local file header and the data, because the data is always near the local file header. So I guess the question arises, why do we need the central directory if we can just go through the local file headers, right? Now the problem is that actually the local file header doesn't have to be at the beginning of the file. That's what I said, that it's wrong to assume that PK letters are always at the beginning of a file, because at the beginning of a file you can have anything, and the local file header can start somewhere else, and this is still a valid zip file, because, well, the central directory will point the parser to wherever the structure is. You can, of course, try to, at least I assumed you can put one in the other, like put one in the comment of the other. However, Ange did try this, and it doesn't really work so well with parsers, so let's just skip it. Now, we are looking for how to parse a zip file. We can actually do it a couple of ways. I already mentioned two, like looking for the end of central directory from assuming that there is a large comment and assuming that there is no comment at all. Another way that is done is we can assume that we just ignore it and go through local file headers and the data. Because we have the size of the data, we can always skip through it and get to the next file, and so on and so on. So this is stream parsing. And well, most of zip files can be parsed in this way because they are proper zip files which don't put any garbage in between. Also, there's something I would like to call aggressive stream parsing, which means maybe a parser can look for this signature in the file, and when it finds it, it can assume, well, this is some file in the zip, and I'm going to try to parse it, try to extract it. Let's call this aggressive stream. Now, I created actually a thing called abstract zip, which merges all these ideas into one file. So you have one file which can be parsed in these 4 different ways using, well, the end way, which is, let's maybe skip here. End first, which is meaning that there is no comment at all. Then there is start first, which means there is a huge comment, and in the comment of this, actually there is this end first, end of central directory header. And also like all the other headers. There's also another stream here, another place in this file. This is actually not linked to neither this nor this. It means this is a separate file, which if you start parsing from the end like you should, you will never encounter. And there is also some syntax breaker, which is actually garbage in between. And after that, there is another local file header with data. Now, let's look how different programming languages react to this. This is Python, and Python does what it should do. It means it actually, when I give it this, this opens the abstract zip file and prints it, and it displays only the end first file, which is the proper way of parsing zip. Now, if we feed it to PHP, I mean, PHP is the obvious culprit, right? If we want something weird, then let's go for PHP. And PHP says start first is in this archive. It's the same archive as before, as Python saw, but it actually reports a different file. And this is fully a different file. Now let's go for some more weirdness, meaning Java. So Java has something called zip input stream, and it does stream parsing. So opening the same abstract.zip archive, well, it sees only the readme underscore stream file, which is totally different. Now, if we go through binwalk, which binwalk is an aggressive forensics tool that is supposed to find many files in a hard drive image, it actually finds all the files, including the aggressive one, and lists them. So that's really good. To sum up this, actually most of the application and most of the libraries, default libraries in programming languages, open end first. They assume there is no comment at the end and start looking for the header from there. I guess only PHP and TCL goes for the start first file. And Java and Ruby goes for stream parsing, this is totally incorrect. I mean, this may pass, but this is totally incorrect. You shouldn't do it this way unless you are like parsing streams of zip, but zip isn't the correct format to do it. And I guess only forensics tools do, well, find this aggressive stream, which is good. Now, I would like to thank these people, Molander, Felix, Salvation, and Yuru, for actually running all this application and these tests for me, assuming that they are all okay and don't have any exploits in them. Thank you. But why do we care? So, well, it could be used to bypass some signing. I actually did during code review find a bug like this, where an archive was verified using end first method, but then it was extracted using stream from the beginning of a file. So this happens. However, what I did, I made 4 copies of this file and started putting the ACAR virus test inside each position. And well, most antiviruses only scan end first, which is actually good because this means that, well, most applications open it this way, so that should be okay. However, there are some applications, some antivirus-like software which try to open it and parse its stream only, which means it never finds the files which are opened by, well, by using most of the applications, which is bad. For all tests, you can see them here. It's a spreadsheet which has all the results.
So I'll go on with the PDF file format. If you're not familiar with the PDF file format, I did a one-on-one with videos and examples. Here's the URL. And just as a reminder, so a PDF file is made of different objects that refer to each other via a structure, via a graph structure. So you see the trailer, the root, the pages, and so on. And basically here, the trailer is the one pointing to the root. And if you have an extra object that wouldn't be used by the other, referenced by the other object, that would be fine. So you can add a, a parasite object, which means that when a PDF reader sees a document, it means it actually found the right trailer and the root object, and then everything can independently coexist in the same file. So basically, if we see the file trailer, it says the start xref line should be preceded by the trailer, blah blah blah, and also importantly, there is a comment. So if it starts with %, it's a comment, and should be ignored. So what happens if you have, for example, this kind of trailer, so one trailer defining a root, but this one is actually commented, this one is normal, and this one actually doesn't have the trailer keyword. So what would happen if those two should be rejected, and actually you can put all those 3 in the same file and you get this. So that's the same file, so that's Chrome, and that's, well, you see, it says this trailer, that's Adobe Reader, and then that's Sumatra, and this is all the same file, and it's not about just a different picture, it's 3 complete different documents. So you could say that on the other way, this is a fake document, and this is an exploiting document for Adobe, and then if someone opens it and doesn't see the right document, they would just ignore the other objects, unless they have some forensics ability. Another problem, so this was clearly a problem with the non-respecting the specs, but sometimes it's in the specs, but the specs are too obscure, and PDF is a very good candidate. So it's like there are so many things in the PDF file format that actually I didn't know about it until recently, and I expect most of you don't know about it. So do anyone see anything special with this file? So first, who is usually using Adobe Reader at some point? Yeah, just for schizophrenic testing, of course. So here what's unusual is that there is this little icon. It's not really a problem in itself. It just means that the file has layer. And this is a feature. And now, do you see what's wrong? So basically, what you see on the screen is not what you're going to print. And this is transparent. When you do that, this is a feature. So because this file has layer, and the layer are playing with the printability and viewability, then you don't have a warning because it's a feature. So now, we can see that's, so it's called optional content configuration, and you can see I define 2 layers. I call them visible and printable, but usually a professional printing document has like 15 layers or this kind of thing. And then you just define default state, export, printable, viewable for each of the layers. So it's even a part of the feature. So there's no warning, and you could argue that you see it in the preview. Then I would say either just leave the page 1 unchanged, or just do a minor change and put your difference at the next pages, or just do a minor change that the people are unlikely to spot in the difference of the file. So in this case, it's not even, it's in the specs. There's not even a magic trick or a misinterpretation. Sadly, it's not so good for POC GTFO because it's Adobe only. And what then displays with other readers that don't handle this feature will vary with various readers. But then you could use the previous schizophrenic type, like with the trailers, so that your trick is only activated under Adobe. So you could, if someone is using another reader, they have a normal document, and if they use Adobe, then they have a document with a printing trap and no warning. So this is very rarely used for a bad purpose, and of course this can be abused for obvious reasons.
Okay, and now let's get to some tricks which I don't think they have some security implications, but they are still funny. So this is a cute little trick I published years ago in Hacking magazine when it was still decent enough to publish in. Yes, so basically the BMP is a really simple format, right? Well, more or less. Anyway, you have a file header, you have another header here, and then you jump into pixel data. Now, there is this BF offset bits field here, which basically points to the beginning of the data. Now, as you might suspect, some applications ignore it, and some applications expect the data to be after the headers, which means that you can put some pixel data here with 1 bitmap, and you can put a proper bitmap here and point to it in the header. And some applications might display, well, proper image, and the other might just go for ignoring this field. So this is one file, 2 different bitmaps again, and this is how it looks. Thankfully, most of the applications actually respect that, respect that field. Another trick, which is something that actually spoiled one of my CTF tasks, but that I created, but thankfully in the testing, is related to compression in BMP. So actually, BMP can be compressed. It's compressed by run length encoding, which is kind of quite interesting, actually. So it has what you would expect from run length encoding, meaning these are the opcodes. One opcode is like you just put the length of, like, for example, 12, and then you put the color. And this means that the next 12 pixels will be this color. Now, you should actually assume that this is some kind of a script rendering the bitmap, and this is not pixel data which is there. Now, the second opcode, when length is set to 0, this is actually an escape opcode, and the next value is more than 2. It's called raw length, which means that you are supposed, or actually the decoder is supposed to expect this many pixels, non-compressed, afterwards, and just copy them to the bitmap, to the output bitmap. Now, actually, BMP kind of extended this RLE. It added 3 more opcodes. One is just end of line, which means wherever the cursor is on rendering the output bitmap, just jump to the end of the line. And there is also the same for end of bitmap, and there is something to just move the cursor by X, Y bytes to a different, pixels to a different position. Now, the question is, I guess, what happens, what data will be in the output bitmap if you just jump over some areas of space? Will it be background? Will it be, I don't know? Well, let's check. Actually, there are 3 options here. The first one is, well, the blank spaces are actually filled with the background color. Here, the background color is 0, which is white. 0 as in the 0th index in the palette, of course. And this is how properly, I think, I expect BMPs should be displayed. If we go for a different viewer, however, it doesn't display it at all, but it displays a different part of a bitmap because it assumes that the missing pixels are all black, and it fills the missing spaces with black. So you can already see what I did with this bitmap. I actually rendered, well, told it to render some background color pixels in these areas and just jump between them. So again, there is nothing hidden here. This is, well, something is actually hidden there, depending on what viewer you are using. And if you use Genome and I think Eye of Genome, the default viewer under well, Genome, you can actually see everything because it assumes the background is just transparent, which is quite weird for BMPs because we are not used, I guess, to BMPs having transparency. But there it is. So basically the same bitmap, but 3 different things you can see. And Ange.
So let's go on with the image and now the PNG file format. So nice trick highlighted with a very cute POC from Dominic from Riversity. So basically you have the same image data that is combining 2 images, and each image is actually using only a part of the colors, but then there are two palettes actually, even though it's a breach over the official specification. So if you use 2 palette data in the file, what happens? First, technically speaking, it should reject the file. Or it at least, will it take the first one or the second one? And so that's a very cute POC, because you see that in one case, so that's the same pictures using the same, no, 2 pictures using the same image data, each of them using 16 colors of the whole palette. And you see that one palette is using the higher nibble, the high nibble of the palette itself, and the other palette of this image is using the lower nibble. So you see it's a way to encode easily 2 palettes in one, and then one file viewer takes the first palette chunk, and another viewer takes the second one. So there should be only 1 palette chunk, but in standard they take the first one and ignore the next ones from now on. But still, in any case, it's against the specs, and this one is the one with the unusual behavior. Most of them just take the first palette chunk. Now let's move on to some executable files. I do some stuff about the PE files, and I won't go into details, because typically the PE file loader, the executables of file format of Windows, is pretty backward compatible, and whenever there was a change over the version, they actually just kill some weird bugs or something. So typically, most of the time when there's evolution, it actually kill something nasty from the past. There are very few differences among the things that change among the version of Windows. So here you have XP, Vista, Vista 7, and Windows 8. And only in the relocation types, there were some variation. So due to a bug, type 4, map to high edge, was actually doing nothing in the case of XP and Vista 7. And that was fixed in the Windows 8. Now there is the obscure type 9 that was used for Itanium, that is doing different results under XP and 7, but now is not supported anymore because they dropped Itanium from Windows 8. Whoa. So actually, now what can we do? So it's very easy to do a difference between those 2 versions or those 2 versions, but, well, I wanted to do Schizophrenic that would work independently on the that would work correctly on the 3 versions, but with a different behavior. So the trick is that you can apply a relocation on other relocations further in the list. So basically, I will use this one to actually patch that one of type 9 into a type 10, and type 10 is hopefully, luckily supported by all the versions. So in this case, it won't do anything, because it's still here because it's not patched. And in the case of Windows 8, my type 9 has been changed into a type 10. I showed that in the POC GTFO issue 2, I think. That's the magazine of Travis Goodspeed, if you're not aware of it. And so basically, the workflow is that my first relocation is processed. Then under XP and Vista 7, it won't do anything. And under Windows 8, it will actually patch relocation 2. Then relocation 2 is in any case, because it's just the next one on the file, is processed. And now under Windows 8, it's a type 10. And then under XP and 7, it's still a type 9, then it creates different results. So now we have a schizophrenic that works in all cases, no error, no bugs, but actually has a different loading behavior, is loaded differently under different versions of Windows. If you are interested in ELF eccentricities, I deeply recommend this talk by Julian Bangert and Sagar Bratus. As you see, plenty of fun with this time the ELF.
Okay. Well, we already had the BMP, we had PNG, time for GIF. Okay, this is, I was also writing some article about GIF years ago, and I stumbled upon this behavior but never made a POC as a schizophrenic POC. Yesterday we talked with Ange and actually came up with this. So you may not, well, I guess all of you are familiar with animated GIFs, right? But animation was added later in the standard. At the beginning there was the idea of having multiple logical images, or sorry, one logical image and multiple physical images. And you define each physical image separately, and you would also tell, well, it would have its size, and you would tell, hey, render this at this coordinates on the logical image. So if you defined 3 distinct images, then it would, well, render it into this. Now, if you defined another chunk, the chunk which was added later and which was the speed of animation, it would actually interpret these images not as physical images in one logical image, but as frames of animation. Now, if there is, again, let me put it a different way. If there is no frame speed defined, that means that this is just an old school GIF with one image. Now, certain parsers, especially browsers, but not only, tend to animate everything. I mean, if they don't have defined the frame speed, they just assume as frame speed, some default frame speed, which means that the image before wouldn't look like this, but it would actually be animated. The first frame is always treated as background, and it's always here, as you can see, but the rest of the frames just like switch. Now, this actually gives us well, a way to create a schizophrenic POC, which means we define the first frame, which is the background frame, again with one image, and then we do quite a lot of frames with like just this pixel, basically rendering in exact this spot. And at the end, we define another whole image. I would like to, well, say that every image has its own palette, or can have its own palette, so these are like 256 colors. Well, so if this is interpreted as an animation, what would happen is that you would see this, and, well, you wouldn't notice this because it's the same color as this, and it would take quite a lot of long time to actually switch into this image. However, if the parser actually interprets this GIF correctly, it will not try to animate it, and it will just jump to this image, and it will show this image. So, for example, Paint and, well, this is Total Commander's viewer, actually do show it in correct way, according to me. However, all the browsers I tested try to animate it, and also IrfanView try to animate it. GIMP, however, was quite, handled it quite well, because it created a lot of layers. It called them frames, but these are actually layers where the background image was the first image, and the last frame was actually the last frame, so you could use it to see both images. Okay.
So now we presented about schizophrenia between different tools. So basically, 2 tools behaving differently with the same file. But sometimes it happens that it's even worse, that actually within the same tool, you have 2 parts of the tool that behave differently, and then it's really difficult. So actually, the first one was WinRAR. When you open an archive with WinRAR, a zip with WinRAR, the behavior to view the content of the file is not the same as when you actually ask to extract. And that was a problem for me when I was playing with polyglots, because I could open the file, but I couldn't extract. So in one case, it was failing, but in the worst case, it was doing nothing. It was starting to do something, then it was not crashing, but not saying anything. So feel free to experiment about that. And also, what we saw earlier, the problem with Adobe, that the difference between viewing and printing, if you think about your next letter to HR, it could have a nice consequence, right? So also on the way to the perfect schizophrenics, we had a couple of experimentations, failures, or maybe just in progress, and we need maybe your input for that. So yeah, we initially wanted to have kind of perfect schizophrenia via on images via color profiles. So color profiles are those complex data that you embed with the file so that the file is displayed, is printed correctly and or rendered correctly on your screen and so on. That's quite complex, to be honest. And basically, you have here different standards of color profiles, and you see they map some colors differently. And what happens if you would use some colors that only works with one profile and not the other? The problem here is that how do you say, not so many easily accessible tool actually handle those. It's really complex. So you know that Photoshop can handle that and so on, but well, for experimenting, just for the sake of experimenting, it's not so nice. And especially creating those files, there are rarely libraries that actually manipulate those files. Those not files, but these the profiles to be embedded with the file. So usually they just open a picture, but they don't care about color profiles at all. So basically, it's difficult to experiment with that. Another thing I experiment when playing with JPEG for another topic was that I saw that Airframe View, even though it's commonly used, is supporting a lot more irregular chunk types than all the others. So basically, you use a buggy, unofficial chunk type. Airframe View is happy. All the other file viewers are unhappy, but I couldn't get the others to work, so then it didn't work. And also a bit like BMP, which has an offset to the next data. I tried with FLV, so Flash video is not so complex in the format. Even typically, we think that videos are huge, but they can be made pretty small. And I tried to get some discrepancy, very similar to the first BMP trick, but it didn't work. Although at some point, I had VLC saying I cannot load this video, but still it was playing some random sound. So maybe there is some possible thing to be found at this topic. I also, yeah, just for, if you remember this guy who said he had write access on YouTube by uploading a video, I created a PDF FLV polyglot and I uploaded it to YouTube, but YouTube refused after it uploaded it. I mean, I still have it on my list. Let's say your file is incorrect. Next try, maybe. But I have writing rights on YouTube. So PNG has many stuff like so ancillary chunks that will affect the rendering levels, like color profiles, gamma and transparency. So for palettes, specifying how, if a color will be transparent with paletted images, it's often supported. Some stuff that could help me for the color profile parts, like significant bits and chromatities, it's never supported. And I was a bit disappointed that something I think useless, like a physical size, which means you define a pixel ratio. So instead of having square pixels, if you want to squish your image, then you say my pixel are actually 2 pixels wide and 1 pixel. It's not really DPI. I think it's pretty useless, but I was a bit disappointed to see it's actually supported anywhere, but I couldn't abuse that. So maybe failures currently, but maybe with some input or suggestions, I will actually make something out of that, or Gynvael, of course. So conclusion, if you think about it, most of these file formats, the specs are public, some parsers is often public, and yet the result is very messy. So sometimes the specs are okay, but in the case, for example, of zip, even now the specs are still very messy, and even worse, the parsers don't even respect them. Then, while it all makes I would say, our security or at the computer, at the software level less strong, then whenever there is such a bug, you cannot claim a CV for that. You cannot blame on full disclosure or anything for badly parsing a picture. So basically, until there is a crash on an exploit or something major like the Android master key bug, then there's nothing we can do to shame, highlight, report, this kind of thing. Our POCs and slides are available at this address. I'd like to thank all these people for their contribution. And so does Gynvael, so he's and thank you for your attention. Any questions?
Thanks as well. So we do have time for questions. If you have a question, please raise your hand so I can raise to you with the mic. Any questions? Just listen to the voices in your head.
He's not that scary.
There's one question over there.
Just a note, if you're looking on the slides, we have a bonus round, so you can go for it.
Yeah, we all know from the security point of view that the TIFF format is a huge mess. TIFF, like in overflows in libtiff.
The fax image?
Yeah, the true image file format.
Yeah.
And have you found something funny to do with this image that are actually multi-page documents and that are really messy?
So I didn't look through them.
The TIFF file
did you
format.
go through it?
I did some experiments with TIFF, but not really for Schizophrenic, or not really. I didn't really try, but thanks for the suggestion.
So on a similar note, we didn't go through like HTML interpretation or CSS interpretation, because why kick the like somebody who's already lying on the ground, right?
More questions over there?
Hi. How many files were you able to put into one file so that all of them were still correct? I think you...
So as polyglots, you mean?
Or something?
So do you mean, as in Schizophrenic, I think the zip one had four different interpretations, if that's what your question is about. I don't believe we did one which had more interpretation. That being said, I guess, like, so I did mention in the zip part that you can look for the end of central directory header from assuming that there is no comment and assuming that there is a huge comment, right? But actually what you can do, you can also start looking in the middle. And maybe if you would like place quite a lot of end of central directories header at different possible locations, maybe something tries to jump in the middle and you would be able to like trick another tool, if that was your question.
One more question.
Yeah, hi. Thank you for your speak. I was wondering with the zip issue, how do the common implementation of Windows or Mac OS deal with not so nice formatted zip files, like the Explorer or the Finder zip functionality?
So actually, they were really boring, as in they didn't do anything out of what you would expect them to do, which was surprising, and I was unhappy about it. But actually, like, I think there's a file manager called Unreal Commander on Windows. If you want to test schizophrenia or like weirdness in parsers, that is the perfect choice because they are like vulnerable to everything.
Any more questions? One more here.
Yeah, on the zip file parsing, have you looked at AV engines and how they process it? Or like when you try and send zip files through Gmail, for instance, have you looked at how they handle it?
I didn't understand, sorry.
Could you repeat?
Sure. With the zip file processing, have you looked at how AV engines might look at a zip file? Or, for instance, Gmail won't let you attach zips, or it'll unzip in a zip file, for instance.
Okay. So with Gmail and unzipping zips, if that is your question, I hope it's all correct because I actually did a security review for that. So that being said, I did test, because as you know, Gmail scans also files for viruses, and I did an ACAR test with it, and it was actually behaving really well, as in I think it found all the instances, so yeah, that was okay.
No more questions? If not, then it's the official break till 4:30. There's actually muffins upstairs, and obviously water and club mate, so enjoy the break.
Thank you.